Check it out. Necomimi something brainwave cat ears. So these guys are supposed to read your thoughts and move some ears around based on what you're thinking. But anyway, there's no videos of this thing being hacked on YouTube, so here we go. I've already taken it apart. It's very easy to take apart. Over here on the headband, you'll find these discs right here on the inside, which kind of press up against your head, and those discs have stickers on them. And then you'll need some kind of really fine Phillips head screwdriver. And the coolest discovery was that the ears that move use standard servos. So if you look over here, we've got the headset, and I've pulled the ears off and I've broken out the wires. So the other cool thing about that fact is now we've got 5 volts. So we've got a servo signal for each ear, so we'll just have to read each of those signals to tell what it's doing. And then we've got a 5-volt wire, which means we can run things like IoT or whatever we want externally to keep this wireless, because we want to keep it wireless. If you just want to see when you first turn it on, I've got my scope hooked up here. So when you hit the power button, the blue light comes on. You'll see the servo signals. So that signal right there is supposed to be the calibration signal. So if you look down there, it says calibrating signal. One ear will perk up and one will drop. So you're looking at the perked up signal and the dropped signal. We got both channels hooked up there. Another really cool thing about this is that it takes 4 AAA batteries to power those servos. But now that we don't have the servos, we have a ton of battery power. So if we're going to do something like run wireless to another microcontroller, then I would imagine that you're not going to have to worry about changing batteries too often, and you might even be able to get away with using nickel metal hydride in there. Or an ear clip, so you clip this to your ear, and then the headband has a sensor that touches your forehead. The headband itself has a wicked clamping action. It's definitely for smaller heads. You can spread it apart a little bit, and then it won't give you a migraine headache for wearing it. But if you've got a big head, you're not going to wear this thing for much more than a couple hours unless you modify it, because it's just got too much clamping. And the reason for the clamping is probably this forehead sensor. The tighter that the headset is, the better you'll get a connection up against your forehead there. So it's really essential that this sensor be up against your forehead. Alright, so I strapped this thing to my head, and I've got my electrode firmly planted in my forehead and the other one clipped to my ear. I've got the oscilloscope hooked up to both of the servo channels, and I'm going to power it up. And you'll see 2 different signals here, one for each ear. And the way that you know it's calibrating is one ear will perk up and one will droop. So that's what you're looking at right here. You've got one a little bit higher and the other one a little bit lower. Now when these pulses become the same size, that would mean that the signal is calibrated. And from there on out, the rest of the servo movements are symmetrical. So what we can do when we interface this to the microcontroller is we can listen to just one of the signals and then compare it against the other one to make sure it's close enough. And if it's in within range, we can call that a good signal. So the first thing that I noticed is that it's taking forever to calibrate right now. If you're actually doing something while this is calibrating, you'll want to stop and enter a sort of relaxed state of mind, because what it measures is everything between relaxed to very active. So this is high focus with both ears. That just means your brain is active. The easiest way to set that off is to look at something and focus on it. Just look at an object. Look at like this exclamation point and just think, exclamation point, exclamation point, exclamation point, exclamation point. And you'll see now that I'm doing that, see I started talking, so it's going to start going haywire again. So after doing this, now we should be able to connect it to a microcontroller, and we should be able to wirelessly communicate whether we're relaxed or focused. And I think for $20, that's a hell of a bargain. The cheapest Brainwave kit that I've seen is $100, and it can do a lot more, but it's $100. So this is just a fun hack, and I'm really looking forward to connecting it to the microcontroller next. And of course, we'll be doing this 100% wireless. That way we don't introduce any high voltages into my brain.